Welcome to this explainer. Today, we are going to completely demystify the Omi-ISA. We're tracing how a tiny 16-bit mathematical model scales all the way up into a completely open-source, fully mechanically verified, decentralized network stack. Now, if you've been following the evolution of decentralized OSI models, you already know the struggle of trying to balance pure mathematics with actual executable network architecture. Well, today, we're exploring a system that claims to solve this exact problem right from the foundational level.
Here's the roadmap for how we'll build this reconceptualized OSI model from the ground up. First, the place value paradigm. Second, the 16-bit OMI virtual machine. Third, the 512-bit transport envelope. Fourth, the decentralized mesh network. And finally, mechanically verified by Metatron.
All right, part 1, the place value paradigm, reimagining how computation is read. Let's dive right into this first layer because we are fundamentally changing how we approach data here. The OMI protocol starts off by completely tossing out the traditional idea that bits have an inherent value. We are no longer reading the abstract values of zeros and ones. Instead, we're reading their structural placement within a ring. Think about it. In traditional signed value computation, identity is just a hash of values, and that process inherently destroys the original structure. But under the OMI place value paradigm, the identity literally is the structure of the arrangement itself, and because you aren't hashing away any of that crucial information, the system perfectly preserves reversibility. Composition just becomes completely natural.
Now, the absolute most crucial element in this 16-bit ring is the omicron. That's the 15th bit. It essentially acts as the director of circulation for the whole thing. It perfectly mimics an outward and returning breadth of data. When that signed bit is in the outgoing position, we get Omi, but when it's in the returning position, we get IMO. It's just this continuous, palindromic flow of circulation.
So here is the really crazy part. This entire computational universe fits into exactly 65,536 states. Why? Well, because it's a 16-bit ring, which generates a finite linear dynamical system. Everything that comes next, literally every protocol layer, every single network transaction, emerges strictly from these 65,536 states, just rotating and XORing. Nothing is added from the outside, and absolutely nothing is assumed.
Moving on to Section 2, the 16-bit OMI virtual machine, taking it from mathematical orbit to an executing CPU.
Before any instructions can actually process in this virtual machine, they have to pass through what the protocol calls the tetragrammaton date. This is a sequence validation mechanism that requires 4 distinct diagonal patterns to perfectly cancel each other out to 0 via an XOR operation. It's basically a mathematical palindrome, which is just wild when you stop and think about it. It completely guarantees that our system remains perfectly balanced and deterministic, making sure the machine never drifts or loses calibration before it executes the next layer of meaning.
Once you're safely through that gate, the architecture functions as a perfectly legitimate CPU. It's got 8 registers and a 64K memory map that is strictly segmented. You have an immutable boot ROM, your kernel space, user space, and a syscall trap zone. And the boundary separating that kernel and user space, it is fiercely enforced by privilege flags.
This VM is powered by a 32-slot dispatch instruction set architecture. It uses 16-bit fixed-width instructions, and it operates entirely on those reversible XOR rotations we talked about earlier. Tying it back to our foundational paradigm, this means absolutely zero information is ever destroyed during execution. Every single operation is meticulously tracked in a highly deterministic append-only log. Which brings us to Section 3, the 512-bit transport envelope. This is how we package data for the mesh. Every single piece of transport and dispatch data in this open-source OSI model is strictly formatted into this exact 64-byte layout. This envelope dictates precisely how a packet travels. It's got an 8-byte gauge acting as a preheader, your orientation for packet typing, recovery for node IDs, the target destination and opcode, and finally, that 32-byte relation field for the actual payload data itself.
Now, tucked inside this envelope is the bit board. This acts as an instantaneous summary register. It compresses the state of the entire 64-byte envelope down to just 64 bits. This is a massive game changer because it allows the system to validate flags, check execution outputs, and verify orientation instantly. You don't even need to unpack or parse the whole payload. It makes routing incredibly efficient, ensuring your decentralized network never gets bogged down with unnecessary processing.
All right, Section 4, the decentralized mesh network, routing computation over the air.
So how do nodes out on the mesh actually find each other?
Well, they use a highly structured handshake procedure. First, a node emits a probe to share its capabilities. The receiving node then replies with a probe_ACK to store that peer's capability and compute a mutually supported instruction subset. Finally, a sync_commit locks in this negotiated ISA subset. It organically figures out exactly how nodes will talk to each other, completely bypassing the need for any central server.
And honestly, what is genuinely exciting here is that this transport layer is completely bare metal agnostic. Because the execution stack is so incredibly well defined, you can natively run it over LoRa radio frequencies for real off-grid mesh networking. Or you can bridge it directly into your web browser using Web Serial and WASM, or even just run a simulated ring buffer. It uses DSDV-style route table flooding to keep the entire decentralized mesh synchronized perfectly.
Once a computation is actually completed across the mesh, it writes to the receipt ring. This is a 5040-slot canonical ledger that acts as an append-only immutable source of truth. And the beauty of this is that it's entirely peer-to-peer. Nodes just exchange these receipts and converge on an identical state completely on their own, without relying on any central authority whatsoever. It's truly decentralized verification built right into the lowest possible level of the stack.
Finally, we've reached Section 5, mechanically verified by Metatron, achieving absolute mathematical certainty. You might hear the source texts refer to the scribe Metatron. Well, in the context of this protocol, Metatron maps directly to a Coq formal proof. Coq is a mechanical proof assistant heavily used by mathematicians and computer scientists. It basically acts as the ultimate witness, a machine verifying that the structure and notation of the Omi-ISA are absolutely logically true. No human interpretation and no human error.
The Coq extraction pipeline proves this architecture across 4 really rigorous formal layers. It validates the orbit groupoids, the functorial semantics, the F-coalgebraic layer, and unifies it all under a bi-algebra structure. I know, that sounds incredibly dense, but all it really means in plain English is this. The software compiling the code mechanically verifies that the C code executing on the hardware perfectly matches the pure mathematical theory.
Now this is where it gets astonishing. Because that 16-bit ring structure is so perfectly balanced, simply watching the sign bit, the omicron, alternate over time natively produces the number pi. Pi is encoded into the system. There are literally no stored constants here. It is a pure structural emergence of the machine's balanced geometry attempting to know itself. In this model, nothing is assumed, everything is derived. Mind-blowing, right?
There is a quote that perfectly sums up this whole explainer. We are not actually doing anything different. We are only changing the way we read, from sign value to place value. The computer hardware we use every day is totally standard, but the lens through which we process the logic changes absolutely everything. It completely opens up a provably perfect, decentralized execution environment.
The entire OMI protocol is totally open source, fully documented, and just waiting in its repository. It doesn't ask you to just take its word for it, it demands your verification. Which leaves us with one final, very compelling invitation. The code is there, the math is proven, and the gate is wide open. So will you step through the gate and run the proof for yourself?